Welcome to Unit 2, Lesson 2C, or Part 3 of Lesson 2 in Unit 2. I am recording this during Tropical Storm Ian, so hopefully my power stays on and my Wi-Fi stays okay. Otherwise, this might not work out the best. And I hope that at least during the year I'm recording this, that everybody is staying safe and dry. So this is Unit 2, Lesson 2C, or Part 3. It's going to focus on factored form as well as reviewing quadratic characteristics or characteristics of quadratics, which we did talk about some of the characteristics of graphs when we were talking about absolute value, and they are the same. We're just going to apply them to quadratics this time. These are the same benchmarks from the previous two video lessons because they are all coming out of Lesson 2 in the curriculum. So for your warm-up in this lesson, you were given this problem. If a parabola has x-intercepts at -3, 0, and 5, 0, what is the equation for the axis of symmetry? And what we hopefully did in class was you were given time to really wrestle with this problem and try to figure it out. And we will follow that with a class discussion. So what sorts of things did you try and how confident are you in your answer? So if you're watching this video from home, you're watching this video to make up the lesson, what I want you to do right now is pause this video and generate some ideas on your own. Don't bypass the opportunity to wrestle with the problem and explore your own ideas with it. Okay, and then I'll go over and summarize this, but I really don't want you to just plow through the video and wait for Miss Taylor to summarize it for you. I want you to look at this and wrestle with it on your own. So go ahead, pause the video right now and take about 5 to 10 minutes on your own to try to figure out where the axis of symmetry would be if a parabola has x-intercepts at -3, 0, and 5, 0. Okay, so hopefully you have some things. If we could have a back and forth through a video, you would have some things that you just tried to do. Now, I hope that one of the strategies that you are beginning to add to your repertoire of things, it's really windy outside, that you are beginning to add to your repertoire of things that you can or should try is to graph things. Okay, so if you were given 2 points, I'll turn the pen on, okay, that you would at least try to look at those points. So let's go ahead and take a look at those points. So we have the point 5, and I'll use a highlighter for actually doing the points. It just helps them come out a little bit better. Okay, now those would be the two x-intercepts. Now right there, if you were just staring at it, this should give you an idea. It gives you a place to start. It doesn't mean you're going to get it right. It doesn't mean that you're going to have tons of confidence. It's about struggling with a problem and pushing through and coming up with something. Now, what we don't know is anything else about this parabola. We don't know if it's like compressed, if it's really wide, or if it's stretched out. We don't know if it is opening this way or opening this way. We don't know. So I'm going to go ahead and just sketch something. Okay, so I'm going to go ahead and sketch something that looks like that. All right. And I know that my axis of symmetry should run through the middle of the parabola. And so I think I'm going to look to see where that middle is. 1, 2, 3. From my lopsidedy looking graph, I'm going to do something here. It looks like it's like right about there. Now, see, this is where the sketch is like, that looks like it's where the vertex is, but as soon as I put that dashed line in it, it just doesn't look right. I was like, that isn't the middle. So let's see if I can get it looking a little bit more middle. And this is exactly what I wanted you to do. I wanted you to kind of play around with it. That looks a little bit better. Okay, now if you have a piece of graph paper, if you have something that can make your sketch a little bit better, then what you might have come up with is it looks like that the axis of symmetry might be at x is equal to 1. Okay. And again, if I had, like if I wasn't freehanding it on a computer screen, I think we might be able to see that a little bit better. So in terms of things that you might have tried to play around on Desmos. You might have tried to plot the points. I mean, hopefully you tried these things. If you didn't try them, really think about why didn't you think to try them? Where did you get hung up in thinking about, well, where could I start this? How could I come up with an idea? So mine's a little bit lopsided, but we'll see what happens in class. And hopefully you did take a moment to really think about this. Now, the idea behind this is that the axis of symmetry, because a parabola is symmetric, the axis of symmetry should be right in between the 2 points. And the reason we know that is both of the points have the same height. In other words, a height of 0, which is another name for the x-intercepts, is called the zeros. That's why. So because they have the same height, the axis of symmetry should be right in between them. And so if I were to count like the distance here, so 1, 2, 3, 4, 5, 6, 7, 8, then 1, 2, 3, 4 would be right in the middle. And that must be where the axis of symmetry is. So the goal of that was to get you to discover that on your own, for you to kind of fight with it, rather than me just telling you. If I tell you, you are likely to forget it. But if you look at it and you can see that connection, then you're so much more likely to remember it. So if you do struggle with I was taking my test and I forgot everything, one of the ways that you can improve with this thing like where we forget everything is to really engage in things like this. It's very safe. It's totally okay if you don't get there. It's just a matter of engaging. So here's the key idea. We know that the vertex is on the axis of symmetry. So I am going to abbreviate axis of symmetry AOS, and that is, did I mention it's really windy and there's a tropical storm outside? Is on the axis of symmetry. Okay, now if you're like, wait a minute, how do I know the vertex is on the axis of symmetry? Okay, so let's do some like little graphs here. Okay, I'm gonna just we'll do a skinny parabola and we'll flip one over. Okay, remember what the axis of symmetry is. This is why vocabulary is so important. So axis of symmetry is the vertical line that runs right down the center of the parabola. And where is the vertex? The vertex is right in the center of the parabola. All right. And don't let me breeze by a statement like that. If I'm saying we know that the vertex is on the axis of symmetry and you're thinking to yourself, wait a minute, how do I know this? Stop me and ask me, Ms. Taylor, how do we know that? Okay. I don't want you just taking my word for it on all of this stuff. So here's the deal. We know that the vertex is on the axis of symmetry. So if we know the axis of symmetry, I don't know that I can fit that in there. The axis of symmetry, we can use the x coordinate to find the vertex. Okay. Let me read that sentence out loud because that's awful. And if you're watching this on mute, shame. Okay. I don't blame you if you're not wanting to listen to me. It's just, you probably need to hear what's happening. So it says, we know that the vertex is on the axis of symmetry. So if we know the axis of symmetry, we can use the x coordinate to find the vertex. So here's an example related to the warm-up. Consider the function y equals 2, and then we have parentheses x plus 3, x minus 5, which has x-intercepts at -3, 0, and 5, 0. Sorry about the spacing on that. So we know that the x-intercept is, or the axis of symmetry is at x equals 1. So once you have an x-coordinate, then you can use the x-coordinate to find the y-coordinate that goes with it, because that's what an equation is. The equation just tells you how the x's and the y's are related. So once you know the x, then you can figure out the y. And here's what it would look like. So we have y is equal to 2 times x plus 3x minus 5. Now, I just made that problem up. Okay, I made it up to connect to the warm-up. But if you're wondering where did you get a 2 from, so 2, and now we're going to use x is equal to 1. Okay, so 1 plus 3. And then we're going to use a 1 again. So 1 minus 5. So 1 plus 3 is 4. 1 minus 5 is negative 4. And then you can multiply that in any order that you want. So you might do 2 times 4 is 8, and then 8 times negative 4 is negative 32. You might be more comfortable doing 4 times negative 4 is negative 16, and negative 16 times 2 is negative 32, okay? However you want to get that. And so now I have the vertex. Remember that the vertex is a point. It is an x-y pair. And so when you state the vertex, you're going to state the x and the y. So you're going to state x is 1, and the y value that goes with that is negative 32. Now, you could check that by throwing it in Desmos. And I didn't put a Desmos window up here, but I might do that in class. You could hop on over to Desmos, put that function in. Sorry. Put that function in, and then actually go find the vertex, and you should be able to see that the vertex is 1, negative 32. Okay, it's not going to probably show up on the first slide. You're going to have to change the window, zoom out in order to find that. Okay, so that is one key idea using what's called factored form. Okay, so we are working with factored form, which we introduced a couple lessons ago. Okay, you probably don't know because I had to go back and fix this recording. I tried to do something on this slide that did not work, and you might be able to tell it from the fact that this is, yeah, there we go. That is not the equation that's over here. And I tried to do something and it was a massive fail, and I ended up on another slide and then ended up having to, it was a mess, and we're just going to move on with life. So anyway, so you can also use Desmos. So let me turn my pen on to do this. And I've, of course, completely lost my train of thought because I had to redo a whole chunk of that. But so you can do that by hand, where you can figure out what the vertex is by hand, but you can also use Desmos. And Desmos is it's not a cheat. It's just another way of getting the information that you want. So I'd like you to pause the video right here and try this one on your own. Okay, y equals 1/2 times x plus 3 times x plus 7, and I want you to find the vertex, the axis of symmetry, and the x-intercepts. Okay, so pause the video. Please, please, please pause the video. Do not just play it through and wait for Miss Taylor to give you some answers. Okay, you pull up Desmos and you get these answers, and then you use my explanation to check to see how you're doing on your own. Okay. So pause the video now and do that. Okay, so hopefully you did that and you take what your teacher says seriously. All right, so let's go ahead and click over here in Desmos, and we're going to do 1/2, and then x plus 3, x plus 7. Okay, and once we have that, we should be able to get the information that we need. Okay, so if I hover over the vertex, I can see that the vertex is -5, -2. Now you know what, I'm going to write it down on a separate piece of paper over here, because once I click off of the Desmos window in the PowerPoint and go back to my pen, it's just kind of a pain. All right, and then the x-intercepts, we have an x-intercept at -7, 0, and then another x-intercept at negative 3, 0. And this, the answers for the x-intercepts should match what you did in the explore activity from a couple lessons ago, where you explored factored form and what kind of information you could get from it. So our vertex is negative 5, negative 2. The x-intercepts are negative 7, 0, and negative 3, 0. And just in case you don't remember that from a couple lessons ago, what we discovered was whatever was in the parentheses there, I don't know if you're seeing 2 pointers, but I am. That's super weird. The numbers match. So you have the 3 and the 7, but the sign is flipped. So if you have a plus sign here, you end up with a minus sign for your x-intercepts. And if you had a minus sign here, you would end up with a plus sign for your x-intercepts. Now, once you have your vertex, then you should be able to get your axis of symmetry, because your axis of symmetry is going to run right through the vertex there, and so the axis of symmetry would be x is equal to negative 5. It's the x coordinate of the vertex. So Desmos is another way that you can get the information other than doing it out by hand. Now the question down at the bottom of the slide there says, does this match with what you discovered in the warm-up? In the warm-up, the goal of that warm-up was to see that the axis of symmetry was going to be right in between the two x-intercepts. So if you look at the location of your x-intercepts at negative 7 and negative 3 there, that the axis of symmetry is right in between them. And so you can explore on your own, and then you can use the graphing utility to back up, what you think that you're seeing there. All right, let's move on. Oh, nope, I have to, this ties into my issue before. I have to end the recording, then click ahead, and then start the recording again. Probably have to do this first few. I told you I really messed it up. All right, that was probably seamless for you, but I had to do some clicking around. It was so much fun. All right, so now we're going to review the characteristics of graphs. And I wrote in there that pesky vocab that is so important, because if you are just trying to memorize how you're supposed to answer certain questions, you will eventually forget it. So you need to know, what are you looking for when you are asked, where is the function increasing or where is the function decreasing? Where is it positive? Where is it negative? So it's pesky, but it's super, super important. So let's go over it and make sure that we are all on the same page with what these words mean. So when we talk about a function increasing, what we mean is this: it goes up from left to right. And what that means is, as you're tracing the function from left to right, then it would be heading upward like that. So I'm going from left to right across the screen. Okay, not this way, like, oh, it's going up, but it's going up from right to left. No, left to right, left to right. So think of that number line. Okay, that number line counts up as you go from left to right. Decreasing just simply means it goes down from left to right. And sometimes what can throw students off is the arrows. So this would be going down from left to right, from left to right. Increasing, decreasing, decreasing, increasing, increasing, decreasing, increasing, decreasing, increasing. Okay, I'll do that one more time. It's kind of fun. Increasing, decreasing, increasing, decreasing, increasing. All right, so that's what we're talking about. Don't let the arrows on the end of the graph make you switch the direction for how you're tracing it. Okay, you always trace it from left to right. The reason the arrows are there at the ends of the graph is just to let you know that whatever the graph is doing, it continues doing that even when it goes off of the coordinate plane where you can see it. It doesn't have anything to do with how we're tracing it. Now, when we're talking about a positive function, what we mean is the function is above the x-axis. That is, the y is positive, because you might be wondering, well, what's positive? Okay, I don't know if probably the computer's not picking up the wind, but it's really windy. And negative just means it is below the x-axis, and that is y is negative. Okay, so when we're talking about what negative and positive, there's a lot of things that could be negative or positive about a graph, like slope. Actually, slope positive, slope negative is the increasing, decreasing. When we talk about a function being positive or negative, we're talking about the y value. So if you were to look at the ordered pairs, it would be the y value. Now, remember that we state these intervals using only the x coordinate. All right, we do not talk about the y coordinates at all. It's only the x's. So whenever you are asked for an interval on a graph, it's only the x's, only x's, only x's. Okay. And now I have to stop the presentation again. It's okay. I got this. Okay, so I think I'm good for the rest of the slideshow. I don't think I have to keep stopping it anymore. I really messed it up. I meant well. Okay, so this is a class example that we're going to work through. This strategy was developed after getting feedback from students and consulting with other teachers. So when we were doing the increasing, decreasing, positive, negative for absolute value, there were several of you that just kind of came up and talked to me about what you felt like you were understanding and where you were having trouble answering the questions. And then I took that information, and because math teachers talk and because we're all trying to teach the same thing, I said, this is what my students shared with me. How is your class doing? What are your students doing? And so we started batting some ideas back and forth. And one of the things we decided to do was we decided to try to do this without giving you guys the y coordinates, because the y coordinates were just causing some issues. Have I mentioned it's really windy and there's a tropical storm outside? So what we decided to do is we decided to remove the y-axis as much as possible. So that's what you're seeing here. It's really hard to do because you kind of have to scribble it out, but you can't scribble it out without obliterating the actual graph or the y-axis. We just didn't want the tick marks on there. But we wanted to give you the x coordinates, which is why you can still see the x's and you can still clearly see, okay, well, this is 5, this is 3, I think, and so forth. And we did the same thing over here where we wanted you to be able to see the x coordinates, but we didn't scale this on the y-axis. The other thing is the directions are to come in 2 steps. So one is highlight. Demonstrate that you know what the vocabulary means by highlighting the section of the graph that corresponds it. And then a separate question asking you to state the intervals. So for those of you that are like, I know what it means to be increasing or decreasing, but I have trouble stating the answer, we've split that up into 2 different questions, which can help us see where in that process things are starting to not go well. So remember that your ideas matter. We are all on a journey to get better at what we do. So when you communicate with your teachers, we start communicating with each other and we're like, okay, what can we do to alter how this is presented to try to make it easier for you, which is why you always want to state what you're thinking or where you're having issues. Okay. So for the first part of this, for the graph on the left, we are going to just highlight where the graph is increasing. So I'm going to grab my highlighter. It's in yellow. And remember, increasing means going up from left to right. So as I start on the left, I can tell I am going up. Okay. And what I'll do is I'll highlight the word increasing. And now let's do the same thing with decreasing. Okay, we'll do decreasing in green. Decreasing means going down. Now, if you can do that, then what you have communicated to me is that you understand the difference between increasing and decreasing, and you're not flipping things around or looking at the wrong arrows or anything like that. I get what increasing and decreasing is. The next part of this would be stating the intervals. Okay, so how do you express that mathematically in a way that, that we want you to express it? So what I attempted to do over there was take the y coordinates off. So you don't actually know how high the vertex is because there's no numbers. Like, I was really intentional. There's definitely no numbers over there. So even if you can count the little squares, you don't necessarily know if the square is 1 unit or 2 units or 5 units. Like, we don't know what we're counting by. What you do know, though, because you do have the number right there, is that it changes over at x is equal to 3. So there are a couple of different ways that you could express this answer, okay? If you like interval notation, you could say that is increasing. Now remember that this is, hang on, I don't have my pen on, negative infinity, and this is positive infinity. Again, I hope you've got the audio on, otherwise you're just going to stare at a scribble and won't know that that's an infinity. You can say that it is increasing from negative infinity to negative, oh, not to negative 3, to positive. I can do this. I promise I can do this. To 3. Okay? Or if you're not comfortable with that, you could just say x is less than 3. Okay? Because less than is to the left. So you could say either one of those is fine. And then it is decreasing from the 3 all the way to the positive infinity. Or you could say x is greater than 3. Okay? If you tend to get your greater thans, less thans backwards, then you might be more comfortable with the interval notation. If the interval notation throws you off because it looks like a bunch of ordered pairs, okay, then go with the inequality notation. Or try them both and just see which one you tend to get right more often, and then that's the one you want to stick with. Now, for the other one over here, we have positive and negative. And so I am going to, again, start by highlighting. Positive means above the x-axis. So positive is here and over here, okay? And then negative means below the x-axis, which would be that region there. If you can do that, then you are demonstrating that you understand what these vocabulary words mean, which is separate from having issues with how do I write it. Okay, those are different things. And so we're really trying to spread this out a little bit. So once again, we are going to focus on those x coordinates. So we have a changeover when x is -2 and then 1, 2, 3. Okay. Now, personally, I think the negative is easier to do because it's only in one chunk there, and you can express that 2 different ways. You could say the interval -2 to 3, or you could say -2 is less than x is less than 3. Okay, so you can use the interval or you can use the compound inequality. Let me positive was the blue and negative was the orange, just so we have it corresponding. Now, the positive is a little bit trickier because you have 2 different chunks for the positive, so you actually need 2 different expressions regardless of which kind of notation you're using. So once again, remember that this is negative infinity out here and you got positive infinity over there. So one of the ways that you could do this is you could say it is positive from negative infinity to -2, and then you need that little u there, and then 3 to infinity. Okay, and that's using the interval notation. The other way you could do this is this. I don't have any space to write it. I'm going to come up here, okay? Is you could say x is less than -2, and then we actually had a really we did, like, the math teachers kind of disagreed on whether you should use the word or use the word and here. I'm actually going to let you get away with either of them. The set theory word that you need to use there is or, and I am more of a set theory person, so that is the word or. X is greater than 3. It really might come down to how the question is asked. Okay. But I'm more of a set theory person, and so it's really going to bother me if you use the word and, because X can't be less than -2 and also greater than 3. Like, there's no number that fits both of those. But if the question is asked, what are the intervals where the graph is positive, then technically, in terms of the English language, the word and is okay. Very uncomfortable, and we did not come to an agreement on that. Okay, so that is a review of the increasing, decreasing, positive, negative. So what comes next? The next thing up is a classwork worksheet. So you may work with a neighbor to complete the classwork worksheet. Use highlighters to indicate that you know where the function is increasing, decreasing, positive, negative. Okay, so use the highlighters to show me that you do actually know what these words mean. Then do your best to state the interval using whichever notation you prefer. It will be turned in for a grade, okay? But you can use either notation. You can work with a neighbor, but just make sure that working with a neighbor is not, my neighbor did it and I copied my neighbor's work. Like, so you both come up with an answer, you compare your answers, you share your questions, your strategies, your reasoning, and then you can come to an agreement on how you want to answer it, okay? But make sure that you're both engaged in that process. For your homework, the homework is page 77 plus. It's actually, I don't have the page open anymore, but yeah, it's in that same section, 45, 47, 49, 53, 59, and 60, part I only like the first part 1. It's like the outline I. You do not have to use, you do not have to produce graphs, since it's understood that you can and should be using decimals for the graphing. So when the directions say graph it, you can use decimals. You only need to identify the key characteristics as asked in the questions. Okay, so anytime it says graph the function and then state a bunch of stuff, you only have to state the bunch of stuff. All right, I hope this video helps. I'm sorry that I messed it up and it got kind of rocky in the middle of that, with me having to re-record some slides. So, but let me know, as always, if you have any questions.